In this video, we shall find the moment generating function for the uniform distribution. The question is given and we are asked to find the moment generating function for the given distribution. For more on this topic, you need to subscribe to this channel. Solution. For the moment generating function, we should recall that the moment generating function is equal to the integral from negative infinity to infinity exponential tx multiplied by f of x, which is the function given. So this f of x is the function given. All we need to do for the moment generating function is just to substitute the given function into this place. So we have the moment generating function to be the integral from a to b exponential tx multiplied by the given function 1 all over b minus a dx. So this is also equal to the integral from a to b exponential tx all over b minus a dx. Nothing has changed. Also, the moment generating function is equal to the integral a b exponential tx all over b all over a dx. We'll bring it out 1 all over b all over a exponential tx dx. So we'll differentiate this function. If we differentiate this function, we'll get 1 all over b minus a to be exponential tx all over t, b and a. The next thing to do is for me to substitute. From integration, we have that 1 all over b minus a will be equal to e, anywhere we see x, we'll put b all over t minus anywhere we see x again, we'll put a all over t. If we watch out, we'll see that the denominators are the same. So we come over to this place. We can now write our moment generating function to be equal to 1 all over b minus a to be etb minus eta all over t. So we multiply this by this. It then means that our moment generating function will be 3b minus eta all over b minus a multiplied by t. So this is the moment generating function for the uniform distribution. For more on this topic, you need to subscribe to this channel.